If you're looking for news related to Kubecon North America, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is a bit special because we are here live from Kubecon North America in Chicago. So I will, like usual in conferences, I will walk through the conference, share the atmosphere, try to get some interviews of different projects. So in the CNCF pavilion, but also trying to identify a few solutions in the observability space, in the security space, and present those solutions to you. So if you enjoy today's content, don't forget to like and subscribe to the channel. So follow me in Chicago. Day one of Kubecon, let's go. But first, I'll need to do some exercises to be ready. So at the end, all those equipment is quite heavy, so you have to prepare yourself.
My name is Braydon Kains. I'm a software developer at Google Cloud, and I spend a lot of time involved in open source observability projects such as FluentBit and OpenTelemetry. And I'm also the creator and maintainer of a popular tool called YAML, which is for formatting YAML. So today I had the opportunity to present at the Observability Day co-located event at KubeCon, and my talk was called "What's the Overhead? Evaluating Observability Agent Performance." It was a talk about the most common problem with deciding whether to install an agent in your workload, which is what's the overhead? What is this going to cost in resources to install? Is it going to be worth it? And unfortunately, with observability agents, there's no easy answer. So my talk was about rephrasing that to be more about figuring out where the overhead might be coming from, some of the strategies to work against it, and how you can evaluate it for yourself. Throughout the talk, I mostly was talking about the different styles of the different parts of the pipeline. The main parts of the pipeline I was talking about was pull-based ingestion, push-based ingestion, processing, and exporting. And I started to go into some of the challenges in each one. With pull-based ingestion, I was mainly talking about how pull-based ingestion is usually a very predictable workload. You're going to somewhere, you're scraping some data on an interval. And because it's a predictable interval, the problem is usually just the size of the data that you're working with. Prometheus scrapes, for example, can get very large, and the larger your scrape, the more memory the receiver needs to the more memory the receiver needs to use to process that. And that happens a lot with all types of pull-based ingestion. If you're scraping too many metrics at once, the more you do, the more you use. So with pull-based ingestion, I was talking about ways that you might want to reduce the size of your scrape, maybe using the Prometheus API to reduce the size of the scrape or reduce the metrics that are appearing in your query, or by maybe if you're scraping process metrics, only going for specific processes. One of the biggest challenges with pull-based is especially if you're processing too much data too quickly. So you can set, and for Prometheus scrapes, for example, you can set a scrape interval. If you set that too short and you don't have other mechanisms like scrape timeout to work against working slowly, then you can very easily overwhelm your input plugin and overwhelm your pipeline by processing too much at once and then needing to process the next set before you're finished with the first set. And that's one of the most common misconfigurations that can lead to extreme resource usage. So one of the big challenges with processing is that a piece of functionality that seems simple, like maybe you're moving a field or maybe you're just trying to parse a timestamp out of a log, as soon as you're sending thousands of logs through that pipeline, that originally simple operation now has a multiplicative effect on your overhead. There's also a matter of like, where do you actually do that parsing? On an input, and in the Intail plugin in Fluentbit, for example, you can set a parser directly on the Intail plugin, like parsing Docker JSON format logs. But if you do it right there, then you're bogging down your tail ingestion when you could be doing it later on down the line instead of, and let the tail plugin do its thing. If you can push any of that kind of processing, especially things like JSON processing, to a backend, if you have that option, I always recommend that you do that, because the less that the agent can be concerned with needing to transform that data before it gets sent out, the less overhead that you're going to use, especially when it comes to processing CPU. It's the big one. It uses a lot of these, especially JSON logs, use a lot of CPU to do that processing, especially if you're doing it a lot. And it needs to start spreading out to more cores because it's processing too much data at once. There are less expensive types of parsing that you can do on the agent to make it easier to send to the backend. Things like dropping a field, or by just checking a value of a field and dropping a log if the field is a certain value. Those sorts of things probably can be kept on the agent, but as soon as you need to do things like process a JSON or do a long regex, those things have a multiplicative negative effect. So any of that processing that you can push away from the agent is the better. Most of the popular observability agents these days, if all you're doing is just shoveling data out to a backend without processing anything, pretty much every agent can do that to a crazy scale. But as soon as you add processing into the agent, the more you add, the more you're hamstringing your potential throughput. So I work on a project called YAMLfumped. This is a project that I work on in 20% time and spare time. I originally created it because there was a hackathon week project on my team, and my project was to add a YAML formatter to our repository, to our main repositories, because we were having issues with YAML being slightly wrong, or like tabbing was slightly wrong in one spot and nobody understood why, or nobody caught it. So I went out and tried to add a YAML formatter to our tool. We don't use Python and we don't use Node.js, but every YAML formatting tool that I could find required a Python installation or required a Node installation. And I really didn't like that. And I thought that it would be pretty easy to make just a small binary with no dependencies that can do this YAML formatting. And so I wrote a YAML formatter in Go. It takes in YAML, puts it through the most popular Go library for YAML, and then spits it back out. And that results in formatting. And when I decided to push it out, I just decided to publish it on I did it on Google Time, so I published it in the Google GitHub org. And then I woke up the next morning and it had over 250 stars. And I didn't expect that kind of uptake. And so the tool really took off and I needed to do a lot more to it. And now there's a lot more configuration that you can do with it. And there's a lot more that I want to do. Now that I know, I think it's over 900 stars now or something. There are a lot more people using it than I realized. And so I'm working really hard to make it more effective for more use cases. So schema validation is one of the things that's on the roadmap. It's definitely doable because there are I have everything that I need to do YAML schema validation. I just haven't built it, but that is up there as one of the things that I want to be able to do, as well as being able to handle some of the more complex YAML formats like Helm charts. Helm charts are a bit weird because they have Go template syntax built in to YAML, but my YAML library doesn't recognize Go template syntax. So that's in a bit of a weird spot, but that's another thing that's on the roadmap that I'd really like to be able to build. For the YAMLfumped project, you can find it at github.com/google/YAMLfumped, YAMLFMT. If you want to find me on GitHub, I'm at Braydon K, Braydonk, or Braydonk if you want to put it that way. I'm on Twitter at RageCage64_. And you can add me on LinkedIn if you're on LinkedIn too, or I am in the CNCF Slack. any of those places you can get in touch. If you want to talk about YAML funk, or you want to talk about agents or performance or logging best practices, any of those things, I am happy to chat about those anytime.
I'm a OpenTelemetry collector contrib maintainer, so that means that I help maintain specifically the collector contrib repository within the OpenTelemetry community, but I also help maintain the collector overall. At Dynatrace, I'm a software engineer on the OpenTelemetry team, so that's my day-to-day role, and within OpenTelemetry, or within the collector, one of my main focuses has been OTTL over the past year as I've been a part of the community. My presentation was about why you might want to use the OpenTelemetry collector to process at the edge. So processing closer to where your data is being produced or somewhere along the pipeline for your telemetry, as opposed to just in your backend, and how OTTL can help you do that. OTTL is the OpenTelemetry transformation language. It's a domain-specific language that's been custom-made for the collector, and the goal of OTTL is to do transformations of the telemetry. So you want to update a field, you want to remove a field, or you want to run a condition on the telemetry. You want to check some feature, some attribute of it before running an operation. And so the collector has a whole lot of processing capabilities that are just built into it, and OTTL helps enable these in a way that's easy to use, easy to read for if you're reading somebody else's configuration, and is the same between OpenTelemetry's 3 signals, traces, metrics, and logs.
So which processors can we use this OTTL?
Today, off the top of my head, you can use OTTL. The big two are the transform processor and the filter processor. These are kind of your one-stop shops for filtering and transforming, respectively. And the other components that you can use it in are also the, I believe, the tail sampling processor, but the routing connector and count connector as well. You can use OTTL's conditions to choose how telemetry is routed, or which telemetry you want to count in the count connector when you're generating metrics.
Could you maybe just share a very basic example of this new language, how it works? So I think you mentioned set attributes or something like this. So could you just explain this?
So I guess an example use case I could give, kind of along what you were saying, is let's say that I want to filter using OTTL in the filter processor. I could check the attributes, which is a type of metadata on OTLP, or the OpenTelemetry protocol. And this describes, for example, where the telemetry is coming from. So maybe I want to check that all logs from a certain pod are dropped. I could drop those with the filter processor. With the remaining logs that are kept, maybe I've got a pod running in Kubernetes that I would like to make some edits to. So to your point on the version, maybe for version 1.0 of an app that's producing certain logs, I need to add a log severity. We haven't set the log level in that version of the app for some reason. So we can do that using OTTL, using the transform processor. And then maybe I need to do some routing. I want to route logs based on the node that they were produced on. And this is a bit of a contrived situation, but I could route them to different backends depending on that attribute of the telemetry. So so it does have a SQL feel to it. So the components of OTTL are, first and foremost, functions. You want to be able to do function calls so that you're not restricted in which operations you can do, and that way you can also you can compose operations. So for example, I could transform a span name to all lowercase before I set it as an attribute on the span for some reason. The other component that you were kind of alluding to of an OTTL statement, which is just one line of OTTL code, are the conditions. So you could say set attribute of span name to span the span name, where the span name starts with the letter T, for example. And that second part is the condition. So you can choose the specific situations that you want a transformation to happen under.
Is this cache storage, is it available for all the signals, or there are a few recommendations on how to use this?
So it is available for all the signals. The cache is basically a map that allows you to carry over state between OTTL statements. So OTTL statements by themselves, the only side effects they can have are by making in-place edits to the telemetry. So you have a payload come in and you make an edit directly on it, and then the payload continues on. You're not allowed to have any variables or you're not allowed to make like database calls or HTTP calls or anything like that. It's all completely stateless. So that's where cache can help. For example, let's say that you have some data somewhere in your telemetry come in as JSON. You'd like to parse this JSON and then access the individual keys in it. Well, you don't want to have to parse the JSON every statement. That would be inefficient. So this is where the cache comes into play. The cache will let you parse the JSON once, set it in the cache, and then you can read from those keys in your subsequent statements.
This OTTL language is being released since how long? And is it in which state is it? Is it experimental? Is it stable? How can the user rely on it today?
OTTL has been around for under 2 years. I came in and started working with it about a year ago when it was previously called the Telemetry Query Language. It was renamed so that the intent was a little bit more clear. And OTTL is currently, by the collector's stability levels, classified as alpha, which means that that we're allowed to make breaking changes to the configuration, but it's used in what I assume are many production environments. So we consider it ready for general use, but we're still making some final adjustments before we want to set a beta milestone to really cement it and say that we think that it's going to be good to go for the long haul.
Day one in Chicago 2023. It was awesome. Yeah, it was good to be here. And we really enjoyed backstage. At least I was at backstage con for a little bit. That was good. Just seeing people.
Senior software engineer, lead software engineer at Cosmonic, and I've been working on WasmCloud, the CNCF sandbox project, soon to be incubating, for about 4 years now, since late 2019. WasmCloud is an application runtime for WebAssembly applications. Our main goals are to orchestrate declarative WebAssembly applications so that you can run Wasm on the back end as a deployment target. We feature a cloud, and edge, and platform agnostic binary, so the WasmCloud runtime isn't tied to any specific platform. You can run it on your laptop, you can run it in a container, on Kubernetes, on bare metal, on IoT. We're really looking for that portable aspect of applications. And what we're really about is just being compatible with, but not dependent upon, a bunch of different services, platforms, and vendors. You already have a pretty distinct investment into Kubernetes. What we do is we publish the binary, but we also lift that binary into a container and publish a Helm chart along with that. So you can just simply apply the Helm chart into your Kubernetes cluster. It can be anywhere from from one of the big cloud provider, GKE, AKS, all those things. And you're essentially running the runtime inside of a pod in Kubernetes, and then you can interact with it the way that you normally do with kubectl, all things like that.
I see here edge to cloud, compute mesh. So what is those use cases? Can you describe them?
Yeah, absolutely. So what we're really focused on is creating real applications that can be distributed across different clouds, different edges, essentially all over, and for the application developer to take on less responsibility. We want the developer to be able to work on features, not worry about how their application is distributed, what platform it's running on, what specific implementation they're using, until they actually need to run it at runtime. So for all of our networking layer, we use the cloud native, the CNCF project NATS for all of our essentially pub sub messaging, so that no matter where your services are running, they can talk to each other like they're just running on your local machine. So this is an example that's actually written in Rust, but I want to show you what it looks like to develop an application with WasmCloud. Like I said, we're really focused on people writing their business logic, and what that means is you can work with common abstractions for cloud capabilities like HTTP servers, key value stores, message brokers, and so what your application ends up looking like is a really abstract representation of the service that you need. So I'm writing an app. It needs to receive HTTP requests, increment a value in a key value store, and then return that response. Very simple business logic. And what that looks like from the code perspective, we have a single function that receives an HTTP request and returns an HTTP response. When we get a little further down in the code, when we interact with the database itself, we're just working with an abstraction of a key value store. We're not actually tying ourselves to a specific vendor here in the application. And what you also notice, this is the entire piece of code for this microservice. There's no mention of how the HTTP request is going to get to the service, how we're setting up our TLS certificates, what key value store we're using. All of this is really important because those libraries, the open source connectors, the things that are working in that sensitive context are usually the pieces of applications that take the most amount of effort to maintain on the developer side. With WasmCloud, you only work with this piece of code, the code that you're writing. So essentially what we do is we instrument each WebAssembly function call, and we support OpenTelemetry traces all the way through the system, again, no matter where it's distributed. So WasmCloud is a cloud-native technology. Traces are a huge part of that. You just give it an OTTL exporter URL when you start up the WasmCloud runtime, and all your traces will go there. You don't have to worry about instrumenting each individual function. We actually don't have OTTL metrics support right now, but we have an open proposal to add metrics. So we're looking at Prometheus, OTTL metrics for those kinds of things.
Oh, that's cool. So at the end, you provide everything, all the required components to make a code reliable and maintainable.
That's right. That's right.
And then people just focus on the business aspect.
That's the goal. I mean, if you look in here with NATS under the hood, you actually get automatic load balancing, automatic immediate failover to available compute when you're running in a highly distributed environment. And again, none of that code is here. You can't actually, all of that is kind of abstracted as a part of the platform. So the developer just gets to write their little piece of business logic. All right, so moving on from just the code, I'd love to actually just show you what it looks like to deploy this. It's a really familiar flow to if you're used to deploying things in Kubernetes with declarative deployments. We actually work with the Open Application Model spec for defining our applications. So you can compile that single little microservice and push it up to an OCI compliant registry. We're not packing it in a container. You can just push WebAssembly straight to OCI registries. It's a really neat part of the OCI spec. And then, like I said, there's no mention in the actual code itself of what port we're going to listen on, how you connect to a key value store. This is when you get to make that decision, when you're going to run your application. So we're going to listen on a local endpoint, and we're going to connect to Redis for our key value store. So taking a look locally, I have that same manifest just running here or sitting here in my terminal. And what I've already done is launched up the WasmCloud runtime, which was just done by using our Wash. We have a lot of fun with puns, Wash CLI. So in order to deploy this app, feels very similar to like a kube control apply. We can deploy the manifests. And if we look at the WasmCloud dashboard, we can see that we have our single application component, the business logic, the key value counter, and the two implementations of services here. If we take a look at localhost 8081, we see our wonderful key value counter demo with a little special surprise of, static assets and some fireworks. But that is essentially what it feels like to deploy the WasmCloud application. It comes by default, but it actually doesn't need to be running alongside the runtime. It can be completely detached. It just works by connecting through the WasmCloud API over NATs. So you can run this even locally on your machine and connect up to the NATs port in order to see what's running in the cluster.
So at the end with this, you can basically have an inventory of all the various WebAssembly components that has been deployed.
That's right, and that's actually our exact command to grab everything that's running in the cluster is to ask for the inventory of the runtime. So I would highly recommend checking out our GitHub organization. If you go to github.com/WasmCloud, that has all of our open repositories, all of our projects, and in the main repository README, we have some good examples for getting started, contributing, and things like that. We'd love to have you.
Shahar Azulay. I'm the CEO and co-founder of GroundCover. So GroundCover is basically reinventing cloud-native observability with a technology called eBPF. We're trying to create a very new and interesting experience around what an APM or application performance monitoring is for cloud-native applications. GroundCover is basically reinventing the entire stack behind observability. From the moment the data is being collected, it's being collected differently with eBPF, which basically means that we can get logs, metrics, application metrics, traces, and basically everything your application is doing in a cloud-native environment like Kubernetes without any hustle or code changes or basically any hard work from the development or the DevOps team. So from the moment we start collecting the data, 60 seconds later, you get all this value out of the box, which is a major differentiator compared to Datadog, New Relic, or any other APM basically in the market that requires a lot of hard work from the user. Then this data is being processed and stored differently in your cloud environment in a very, very interesting way, so we can price the data differently, which is one of the most difficult pain points right now in the market. People paying unpredictable prices, high surges in cost. We price it differently only by the size of our infrastructure, and all thanks to this different tech stack basically collecting and storing the data. eBPF instrumentation is basically a bit different from regular instrumentation. Regular instrumentation like OpenTelemetry SDK or Datadog SDK would require you to instrument your code, basically change your code and kind of say in some languages even manually where do you want a trace to be collected or a metric to be created. eBPF does all that out of band from the application, running in a different container basically that loads an eBPF program to the kernel you're running on. So in Kubernetes, it amplifies because this kernel is a node running 150 different containers on top. Some of them in Java, some of them in Python, some of them aren't even yours, like Nginx or whatever your third party you're running. We would see what each one of them is doing by instrumenting the network and application layer to see traces, to create metrics from these traces, and even collect infrastructure metrics with this instrumentation coming from the eBPF sensor. So in a sense, suddenly a DevOps person can instrument applications by just throwing an eBPF sensor like GroundCover on a huge cluster, and suddenly the dev is not part of this instrumentation process. So it kind of changes the dynamics about what instrumentation is. I can instrument application even if I'm an infrastructure guy and not the person writing the application. So that's kind of the game changer experience in what we do.
And if, for example, an application is already producing OpenTelemetry traces or OpenTelemetry metrics, do you have the options to also ingest that data, or do you detect it automatically and you get it there directly?
So there are multiple ways, but GroundCover has chosen to, we collect the data in a proprietary way using our eBPF sensor. That's clearly not something anyone can do. We put a lot of effort in creating this experience, but we do believe in open source, so anything we communicate is using open source technology. So for example, all the metrics we create with this eBPF sensor are stored in Victoria metrics, which is Prometheus compatible. So we can scrape your Prometheus metrics or integrate with any Prometheus metrics you have or cloud metrics you have in the cloud. And also with the traces and logs, basically our sensor uses the OpenTelemetry protocol to report the logs and metrics and traces we collect to the databases we use. So we actually even run an OpenTelemetry collector as part of GroundCover. So if you do have OpenTelemetry instrumented in your serverless or in somewhere outside of Kubernetes or even in Kubernetes and you want to get more out of it, we know how to seamlessly integrate it into GroundCover because we totally believe that if you've done the hard work, we should kind of show you that on top of the entire kind of vast data you would get from eBPF. Basically, GroundCover has multiple verticals that it supports, and everything you see here is created instantly once you deploy the sensor. So the first bit is like an infrastructure monitoring layer, which is very Kubernetes native. So you would see basically your workload, and you would see red metrics like requests per second, error rate, and latency, but also CPU and memory utilization from that workload. And you can also dive deeper into like pod granularity and container granularity and see what's going on. You would also see the logs collected from this container like instantly, and actually the deployment YAML in case you want to kind of investigate on what's going on inside the actual container. We also create a full dependency map. So in a sense, by collecting all these traces seamlessly with eBPF, we know how to create maps like this of showing you, who's communicating to who. Front end is talking to the shipping service or whatever, and behind each of these edges, there's actually raw traces collected with eBPF. So you can start investigating those and drill down. I can show you an interesting use case where you're a developer basically building front end. You would know that all the metrics about front end, who is communicating to and what in what rates and what error rates. But you can also get a dedicated screen for your use case if you're developing the front end environment. And basically it will contain everything you want about this service. Sorry about the internet here. So you would see like the request per second and error rate and who is it communicating with, but also you get to see issues that we kind of aggregated for you around your workload. So you would see here, for example, a 500 on a /product/asterisk. That's an API your service is exposing. And there's problems with it over the last 15 minutes. So once you drill down, you can actually get real traces that can help you troubleshoot. So unlike OpenTelemetry or Datadog or any other solution in the market, GroundCover also collects the actual payloads of the failed request. So you can troubleshoot with the actual response request, the headers, and whatever you need to kind of figure what's going on. You would also get like the container info, what node is running on at what time, with what's the environment variables, and the logs around the incident in case you kind of want to troubleshoot with logs. But also the context. I mean, was the container close to its limit? Was the node busy? Do you have any reason to be concerned about that? You would get all that. We also support an API catalog, which is a really interesting experience. So imagine you're using some kind of managed Postgres. You would see all the queries in the cluster, and you can easily see who's the slowest one and why, and kind of drill down into the actual query that happened and kind of slowed you down.
And do you provide also profiling?
So we do provide profiling as part of the tracing experience. So in case you have you're looking for a specific trace, you can filter down any trace you would like. And we also, as I mentioned, support integrations from things like OpenTelemetry, and you will get the full distributed flame graph of the trace, and you can kind of start troubleshooting on that. Regardless, every time you kind of investigate a trace, you will get a lot of information around it, like the logs and context around that.
And so, if I, for example, have a service mesh in place where you have some policies that were rate limit or timeout to the request, would you detect those policies as well, part of your service graph that you were showing us a few minutes ago?
So we would actually see for example, the Istio components. We actually know how to integrate with Istio and get data from Istio, or show you the Istio sidecar. So if the Istio sidecar, for example, is slowing you down due to some overhead, we would see that actually the trace.
And on the alerting side, how do you do alerts? Do you have like a threshold-based alerts? How does it work?
So we have a few different experiences. One of them is issues or monitors. Basically, we create issues on Kubernetes metadata or API DB queries, cache queries out of the box for you, and you can kind of set alerts on these. Or we support a fully managed Grafana experience inside GroundCover. So all of these metrics that we just talked about, all these application metrics and infrastructure metrics, everything is kind of owned inside our own Grafana experience. So you can create a dashboard, set alerts on that, and let me just show you an example. So you can, for example, see stuff like infrastructure metrics. You would get all these metrics and you can build your own dashboard to whatever you like and kind of start creating dashboards that you can set alerts on them inside Grafana. We're compatible with Slack, Teams, Opsgenie, whatever contact point you want to give the alerts to. And this is kind of Grafana native, so people using Grafana or using Prometheus, it's super easy. And if you're using Datadog, we can easily migrate all of your dashboards and all of the alerts to GroundCover.
And do you have like a freemium plan, or how does it work? If I want to use GroundCover, or can I use it? Do I need a specific license, or how does it work?
So GroundCover has a free tier. You can start off with 1 cluster up to 3 users. No matter the size of the cluster, you can install us on a huge production cluster if you want to try it out. Once you get to over 1 cluster and over 3 users, that's where our team plan kicks in. But using our free tier is a great experience to kind of use the product. It's fully self-serve. There's documentation. You can find it on our website. You can install it in 60 seconds and start enjoying the value. And if you find it interesting, you can contact us on our Slack community support, so you can help you out on Slack. People these days don't want to talk to people outside of Slack, so we're trying to be compatible with the community. So yeah, it's all accessible.
David Korczynski, and I'm with the CNCF Fuzzing team, and we do a lot of fuzzing of CNCF projects. So I'm a security expert as such. Fuzzing is a way to, it's kind of like testing on steroids, we often call it, and it's a way to pass pseudo-random data into your application. So the essential goal is to take your software package, identify some entry points into this software package, and then just send a lot of arbitrary data to this software package with the goal of seeing if there are any unexpected behaviors, if there are any vulnerabilities, and so on. And I say pseudo-random, but in reality there is a ton of sophisticated techniques underlying the generation of the input you send to the application. And there's like many academic papers on the topic, so it's a structured stress attack on your application. It's closely related to testing, and it traditionally comes from the memory unsafe world, where the goal is to find memory corruption vulnerabilities, and it's now kind of like expanding out to also memory safe languages, not just memory unsafe languages. So CNCF fuzzing is all about fuzzing, but in order to identify what part of an application to stress test, you often need to have an understanding about the attack surface, the threat model of the given project. And it's also very closely related to security auditing. So often these three will be correlated, and you will also see, for example, security audits, which are performed by some of the same engineers that also use fuzzing, and they often kind of interact a little bit with each other. So in that sense, you have to do a bit of, it's not just writing these stress tests blindfolded and see what happens. There is a lot of sort of preliminary analysis needed. So in that sense, you do extra work, but the goal is to get fuzzing, and most importantly, get sort of continuous fuzzing of your CNCF project.
So which project at the moment has been fuzzed?
Oh, quite a lot. So some of the early adopters of fuzzing was Envoy. I think they started fuzzing, especially continuous fuzzing, by way of what we call OSS fuzz, which is like a continuous fuzzing service for free, open source. And Envoy, I think, started in 2017 or so. But many projects, Istio, Fluentbit, Vitesse, Knative, Caverno, Linkerd, Flux, and Helm.
And how can an open source CNCF project can use this service?
So it's not a service per se. It's a bunch of CNCF fuzzing is a team of people that work with maintainers to get your project fuzzed. And what that means is we write the testing logic that you need to do fuzzing. You need to implement some source code. And so the way a CNCF project would become fuzzed is you would reach out to us by way of, for example, GitHub. So we have a repository, github.com, CNCF and CNCF fuzzing. So there's a dedicated repository with a lot of resources, references, example fuzzers, and a lot of source code related to fuzzing of the existing CNCF projects. And you can just create an issue there saying, hey, we're from this CNCF team. Would it be possible to get your team come and fuzz our project? And then likely we will try and engage with you and do what we call a fuzzing audit engagement.
And what type of, by curiosity, what type of tools you're using to fuzz those two projects?
So fuzzing relies on is essentially just executing your code in a certain way, and you have to have, for example, the way you do this is you build and compile your code and then you run it, but you have to do it with, for example, a compiler that supports instrumenting your code in a certain way. In that sense, we use the tools you normally use because most compilers, or like the modern compilers these days, support these things. And it's all open source, it's all kind of like free available. So the tools we use varies a little bit from language to language, because you have to approach it slightly different whether you do C++ fuzzing, whether you do Python fuzzing or Golang fuzzing. But in general, we use the recommended fuzzers for those languages. I think perhaps the key tool, which I should comment on, is we use this tool OSS Fuzz, which is an infrastructure for continuous fuzzing. And what that means is when we develop the fuzzes, we put them in your repository or in the CNCF Fuzzing repository, and then OSS Fuzz will essentially forever, once a day, build the fuzzes against your code and run them and monitor if any bugs are found. So that's kind of like a tool we use to make sure that the fuzzes will run when we don't work on the project anymore. And the goal is there to find regressions or just allow the fuzzers to explore more of your code.
Okay. And if I'm, let's say, if I do myself some activities, how can I become a member of CNCF Fuzzing? How can I contribute back to this project?
Yeah, so we don't have I don't have a clear answer to that at this moment. We would like to engage with more people that are interested in doing this. So I think my answer to that for now would be go to the CNCF Fuzzing repository and make an issue, say you'd like to help, reach out to us on Slack. You can find me, David, and David Korczynski, and I'd probably go with a GitHub issue for now and just say, I'm interested in joining. What can we do? And we'll take it from there.
All right.
So, hi everyone, my name is Ken Finnigan. I'm an OpenTelemetry architect at Lumigo. Previously I was at Workday, and prior to that I was at Red Hat Middleware for many years. Lumigo is an observability solution that's focused on troubleshooting for developers, helping them get to the root cause of their problems and enabling them to solve them a lot faster. Some of the key ones are capturing the payloads from the requests with custom instrumentation, which gives the developers deeper context to what's going on between their calls and execution threads.
So you mentioned here one-click OpenTelemetry. So what does the one-click means?
So the one-click is we have an operator that you install into your cluster, and then install a resource for that operator in the particular namespace you want to monitor. And then it goes through the process of, for anything that's Node, Java, or Python, it adds the agent that we have, which is upstream OTTL plus our custom instrumentations, into the container to start monitoring those, and it feeds the OTLP traces to our backend. At the moment, it's focused on Java, Node, and Python, but we basically take everything from the upstream and then add our pieces on top of it. Our operator does, when it installs and starts watching the pods that are running in your environment, it also sets up a local OpenTelemetry collector pipeline, which will receive the traces, handle them locally, and then send them off to our backend endpoint. So we can handle some level of back pressure locally if there are any network issues communicating to the back end. So here I have Lumigo, and I've created a new project, and I'm presented with the quick start of getting started. And because I'm running in Kubernetes, I'm going to say on Kubernetes. And then we have a couple of options there. We can do the auto trace, which uses the operator, as I talked about, or you can manual trace if you have specific languages that we don't cover. So if I select auto trace, we then come up with the commands that we need to run to install the operator and get it running. So let's give the cluster a name for Kubecon. And then it installs the operator into the cluster in its own namespace. So with that done, we then copy the secret, which gives us the token to communicate with Lumigo. And I just need to go back and set the namespace that I want to monitor, which is in this case just called webinar. So I've got the secret installed. And then the next piece is grabbing the resource to install for the operator to tell it we want to monitor that environment. So once again, I just need to tell it the namespace that we're going to be running in.
So do you have a specific CRDs that you use to configure the operator?
Yes, there are custom CRDs for the operator that define what's needed. And I can show you some of the products. This is the dashboard that gives you the details of what functions or failures might be experiencing. We have a issues tab here, which gives you insight into the types of errors you're seeing in your services in your cluster. We have a Kubernetes page in here, which gives you details of the workloads that are running, the success and failure rates, and you can go into the details and see the events that are occurring for those pods. So this will give us details of like, in that case, nothing. Let's go back and see if something else has a, oh, hang on, I know what it might be. Let's give it a little bit more data time. So it gives you details of like container creation, pulling the images. If there's any crash loop error backups, that'll appear in here as well. I don't know if there's any of those. No, nothing in particular there. And then you can also look at the system map, which gives you an overall view of all the pieces of your system and how they're interacting with each other momentarily. So that's an example of this application here. There's many different components to it. You can also then filter for like which ones are using the most memory or which ones are the most expensive to run, and various other factors as well as latency for the service.
And do you have like an alerting concept, or is it based on threshold? How is it based?
We do. We can create alerts, and you can define alert policies. So this has a whole bunch of alert policies already in here. So if we have a look at one of these, let's put that one. So this is like an alert type, and it's based on the number of errors in the last 10 minutes. So we're saying if there's more than 50% of errors of these invocations for a particular Lambda, then we want to notify, could be Slack, could be email, could be anything.
And you mentioned some Kubernetes events and conditions of some of the workload. So do you interact with the API server of Kubernetes to get that details, or
yes.
do you rely on
So
specific exporters as well? Or just...
So the operator is doing that piece of listening for those API events from Kubernetes itself.
Okay.
To track that information, and if it's related to the pods we're actually watching, then we'll pull that information and send it off to the back end as well.
So then all the traces you use probably the Kubernetes attribute processors to
yes.
Enrich the right metadata, so then everything is indexed when
yes.
it comes in Lumigo.
Correct, yep. Yeah, so we use the Kate attribute processor in the pipeline we have to pull that information and attach it to the necessary traces as it sends back.
And you mentioned that you were capturing the payload and the HTTP request and the HTTP response. Can you show us this piece?
Yeah, so let's have a look at a particular transaction over here. So this is like coming in from the issue perspective, seeing the particular details of that issue. So we can see its execution here. We have a stack trace saying that the write ID can't be empty. We have details of past invocations. We also have context of how many other services might be experiencing the same error to figure out what the blast radius is for the problem. If we delve into the request flow map here, so we can see that we have the stack trace, but we also have the event from this Lambda that was passed into it. So we can see that the write ID in this case is empty, which is why we're getting an exception. And if we refresh the flow here, we now get the detailed, there we go, detailed flow of what this is. And diving into this, you can see all the details of the requests and work your way up the chain to figure out what's happening by tracing the payload through each parent request. as we can see here, we have our service is like essentially marked with a red circle on the flow map there, which tells you that there's an error in that particular piece of code. And then you can delve into there and look into the details. And you're able also to see we correlate the logs if you're running on AWS right now. The logs from CloudWatch can be pulled in and correlated. So for this particular case, for this failure, we can see that there are like 4 log messages associated with that particular request on that pod.
Okay, cool. So if I want to get started and use Lumigo, how does it work? Do you have a feature, freemium?
So we have a free plan where you can have up to 150,000 traces, totally free. And that's as simple as going to lumigo.io. You got the big Get Started button on the home page. Click that, create an account, and you can be up and running, and you'll be presented with the quick trace page I showed earlier, where it gives you the option of are you running on AWS EC2 or are you looking to do Kubernetes.
That's it for today's episode related to Kubecon North America. As you can see, there is a lot of interesting solution in the observability space. I think GroundCover is interesting. There is also Lumigo, which is bring another angle to the observability space. A couple of also interesting projects like the CNCF Fuzzing. That was a great way of making sure that the projects are secured. Again, if there are any solutions that you would like to show or have a deep dive, let a comment below. And because I did so many interviews, there will be several episodes related to Kubecon North America. The second part will be delivered soon. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for the second episode on Kubecon North America.